Today we'll talk about some more about the normal distribution. We've been working with it for a number of lessons. We already know quite a bit about it. We know that if we draw the number line and we draw the bell curve, the mean is that center point, everything's symmetric about that. And we've been learning about the standard deviation and how we've talked about percents of the data that are between one standard deviation to the left and right, or two standard deviations, or three standard deviations. We haven't talked a lot about the standard deviation means how spread out the data is. So you have this picture on your handout. If you have a smaller standard deviation, the graph is steeper and narrower. That means that those three standard deviations, that 99% of the data, is all really, really close to the mean. And we like it on a test, at least I think you guys like it on a test, if the mean is, I don't know, 96, and we've got a real low standard deviation, everybody got really, really close to 96. You guys would be pretty happy, and I would be too, right? The more spread out it is, that means some students did really well and some didn't do nearly as well. They were farther away from the mean. And so a bigger standard deviation, like it's in color on this one, but green, the fattest and lowest one, it's more spread out. One of the most practical applications for students would be SAT data. It is normalized every year so that out of each part where the max is 800, they normalize it so on that math portion, the mean would be 500. Some years, depending on who's taking it and depending on what the questions are, they might be more spread out. There might be some higher scores, some lower scores. But to make it fair for colleges to use for the sake of comparison, they normalize it so that you aren't penalized if you happen to take it a time that there were harder questions. Nor do you get an unfair advantage if you happen to get a little bit easier version. It's normalized to show how you compare to everybody else who took at that particular time the test was given. And they always make sure, as part of that normalization, that the standard deviation is 100 on there. So with these percentages that we've learned, that would mean 68% would be one standard deviation below to above, so between 400 and 600. 95% would be between 300 and 700. About 99% between 200 and 800. So you kind of see what's going on with that to make it a normal curve. We are going to solve problems now where what if we wanted to know just what percent was above 300? Not between two things, not symmetric about the mean. Or what if we wanted to know percents that had nothing to do with exact standard deviations? What if we wanted to know the percent that scored above 450 on that math portion? That wasn't within one standard deviation or two. It wasn't one of the percents that we've memorized. But we could ask questions like that. We are going to strictly use the calculators to do these. I am not going to give you credit if you do the z-scores the way that it does in the book. So pay attention to the notes on this handout. Pay attention to what I'm saying. On the Inspire, it's going to be menu 552 when we get into doing a problem. Menu, and then this is probability because it's what percent, distributions, normal distribution. And then when we look at that, both 1 and 2 say things about normal distributions. Number 1 says normal PDF. The number 2 that we will use means cumulative distribution function. That means we are mostly talking about, well, what is the percent accumulating all the way till we get up to here? Kind of like your cumulative GPA is for all your years of high school, but we also talk about your GPA just for one particular semester at a time. So same thing with the word. So that's why we need the one that is number 2 on there. If you have an 84, you've got the directions over there. This next part is important because since we're going to do this on the calculator, The calculator is going to do all of the work for you. Here's what I need to see on your problem set boxes to get credit. Draw the bell curve like you've been doing, label the numbers that you've been doing. Then, because the problem's not going to ask you about those 1, 2, and 3 standard deviation percents, find the numbers that this problem is talking about and shade that area on your bell curve. And you'll see that on the examples we're about to do. Then we're going to make the calculator do all the work. And you always, our rule is always, if you pick up a calculator, you have to write down on your paper what you type in on the calculator. So you are going to write these 4 words: low, high, mean, or the symbol, standard deviation, or the symbol. And what are the 4 numbers you put into those boxes on the calculator? Then the calculator is going to give you a decimal. You're going to change that to a percent and write it down with 3 decimal places and a percent sign. So you need to be sure your calculator settings are on float. And this is all, well, this part isn't so much, but the other part was all on your notes of what you need to do. So let's illustrate this with some examples now. And these are the same problems as are on your paper. I think the wording is slightly shorter on your paper, but the content is the same. The mean weight of babies born in a metropolitan hospital for 7 years was 6.8 pounds. So we're going to draw our bell curve with a horizontal line under it so that that's our number line. And we're going to label that center point 6.8. Standard deviation is 0.8. So we're going to go out where it almost touches the number line and draw a little mark and then divide each of those into 3 sections. And then we're going to do what we've been doing and add the 0.8. So we have 7.6, 8.4, and 9.2 if I added correctly. Subtracting 8, we have 6.0, 5.2, and 4.4. And then this problem does not ask us what's the percent between 6 and 7.6 or any of those other numbers that we wrote down. It asks us what percent weighed less than 6.4. So we need to find where 6.4 is on there. It's not one of the numbers we've already labeled. It's between 6 and 6.8. In fact, it's exactly halfway between 6 and 6.8. So we draw a line halfway between those two, and then we shade everything less than 6.4 because that's what the problem asks us to find. Now remember, this bell curve goes forever to both ends. It gets really, 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 really close to the number line, but technically it goes to negative infinity and to positive infinity. So technically the lowest end of this thing is negative infinity. Well, that's not a number on our calculator keypad. So we know somehow we're still going to have to write down low, high, mean, and standard deviation. So on our calculators, we know that we want to enter minus infinity up to 6.4. But we've got to figure out how we're going to do that. So make sure you're on a calculator page in a document or the calculator scratch pad. Menu, 552. And then it has negative 9 times 10 to the 999. That is so far out to the left on the number line that it's close enough to negative infinity, but I don't want to have to copy that down every single time. So if you are using the default on your calculator, the one that's already shown on there, you may write down that you are just using the negative infinity. You could write out the word default if you wanted to, but that's longer. Trying to get us something shorter to write there. Then you're going to put 6.4 in for your high, 6.8 in for your mean, and 0.8 in for your standard deviation. So let me do that on mine as well here. 6.4, 6.8, whoops, and 0.8. And is everybody getting a decimal like this? 0.3085375. Thumbs up, thumbs down. Are we all seeing that? And so we're going to change that to the decimal form, or to a percent form. Of what was it? Try to get it where I can see it enough. 30.854 with the percent sign. And these would be the things you would need to have in your problem set box. The bell curve labeled and shaded, the labels, low, high, mean, standard deviation, the numbers that you put in for those, and the percent that you get written with the percent sign. Question? Okay, moving on to the next example. Same data, so you probably are going to want to redraw a little curve on the back or whatever because of the shading. Even though the numbers are the same, it's kind of hard to tell your shading if you use the same curve over and over. So we still have the 6.8 in the middle. We still have 7.6, 8.4, 9.2, 6, 5.2, and 4.4. This time we want between 6 and 7 pounds. 6 is one of the lines we already have. 7 is not. 7 is between 6.8 and 7.6, but it's not halfway between them. It's closer to the 6.8, so we draw this line closer to the 6.8 than to the 7.6, and shade in between. This time on our calculators, we're not going to use the default. We need to change it to a low. The high will be 7. The mean will still be 6.8. The standard deviation will still be 0.8. And I would like for you to punch that in on your calculators and let me know what percent you come up with. What did you get? Thumbs up, thumbs down. Did you also get 44.005%? Any questions with that one? Okay, this next one is going to be a little bit different. Still the same curve, but probably need to redraw it since we're going to be shading a different part of it. So the 6.8, got the 3 sections there, the 4.4, 5.2, 6, 7.6, 8.4, 9.2. More than 7.2, that's again between 6.8 and 7.6, but that one is right at halfway in between. Write out our words, low, high, mean, standard deviation. What do we put in for our low? 7.2. We'll come back to the high in a minute. Mean 6.8, and standard deviation was 0.8. And we're going to experiment with this one. I'm going to have each row enter a different number for the high. So I'm going to have this row over here. You guys enter, how about 9.5? You guys enter 10. This row, 11. This row, 12. This row, 15. This row, 20. I'll enter 100 on mine. And then we'll see what we all get. So we've just done our experiment with guessing different things that we might enter for the max value, and we got similar answers But the bigger the numbers were that we put in for the max, the farther out to the right we went, the numbers became where the calculator showed us the same digits. And certainly for the rounding that we would do, by the time we get down near the bottom of this list, we're all going to round it the same way. But the first people would round it as 30.817, and then we'd have 30.851. So we'd be getting a little bit different numbers if we use those really low choices for the maximum value. So we are going to put in something that's big enough to get the max value so that we would end up with that percentage 30.854, that we aren't going to see any difference in there. The way that the general rule is you need to go, if you're going to infinity, at least the mean plus 5 times the standard deviation. The standard deviation on this one was 0.8. So we'd need to go 5 times 0.8 is 4. So we would have taken the 6.8 plus 4. So if we had gone to 10.8 or higher, we should have gotten what we wanted for the correct rounding. So you'd do that calculation and you'd pick something bigger than that. So you could have picked 11, you could have picked 50, you could have just said, I'm just going to put in 100. I know that's plenty far enough out there. If you were using a calculator that did not give the default for negative infinity, you would have used this same way to calculate the mean minus 4 times the standard deviation. So the 6.8 minus 4, we would have gone at least to 2.8 or farther. Does that much make sense to everybody? Yes. Because default means that's what they're going to display in there. And we're not going to do from negative infinity to positive infinity because we already know that's 100%. So the calculator thinks that's silly to fill that in, so it's filling in the one that you use most of the time. And there's also a way you could flip it and do it just with that, but it's easy enough to do it this way, and I think that's easier than trying to flip it around and figuring out the symmetric values to put in instead. Okay, one last example. A little bit different vocabulary in here. We will need to talk about what percentile means, but this time we have a mean of 45. So we draw our curve real fast here. And we're going to add and subtract sixes. So 51, 57, 63, 39, 33, and 27, I think. And we want to know percentile if a student scored a 54. Okay, so 54 is what I'm interested in. That's right there halfway in between the 51 and 57. Percentile means higher than what percent of others. So for the test, higher than what percent of students. Sometimes at the doctor's office, taller than what percent of children the same age. Way more than what percent of children the same age. And they'll give parents reports and graphs about percentiles for the growth of the child. So we want to know with a 54, that is more than what percent. So we're interested in everything that's smaller than that. So we're going to shade all of this and see what percent we come up with. So we are going to put in low. We can just use that default for negative infinity. High 54, mean 45, standard deviation 6, and let me know what your calculators say. Okay, what did you get? So she scored higher than 93.319%, but percentile usually just uses integers. And so we would say in the 93rd percentile. I would like to see the decimal so I know what your calculator showed and see the percentile answer on these. So what do you guys think? Pretty easy once you know that on the calculator? All right, good job today.